right. I'm recording this session.
Can you go over the homework problem? Is that a possibility?
Yeah, I can go over homework problems. I have all the answers right here.
Did you do them before homework? So yeah.
Like I probably spent like 2 hours on this, I'd say. Like also it's not.
We also like briefly go over the randomized select algorithm.
Yes. Isn't that 9.2?
Yeah.
Yeah. Can we just go over that one? I think I'm good with 9.2.
Yeah, the min
Yeah.
Sorry,
This one.
yeah.
Show the randomized.
You guys said you guys were good with 9.1?
Yeah, the min.
They seem doable.
That was yeah, it was on the midterm. Yeah, it's a last question. It's a last question.
I don't know what it said on that.
Me either. I read that because I was reading chapter 9 for LSS. And I read it, I was like, shoot, I think I got that wrong. Or I described it wrong, but I get it.
Yeah, I just said a bunch of words in English and then
I did mention it in the section actually last week. I did mention it. I believe I mentioned it, or maybe not.
Wait, can you tell us the question that you were trying to fix out that you were like,
yeah,
you did it in class, but I like
It was that one. It was the one
the min math?
on the
you didn't
No,
do it in class.
You did.
What?
Like the week before. He briefly did.
Yeah.
Wait, is that the one that you said was too hard to be on the midterm? But he was like,
Yeah. I mean, I will say most people got it wrong. I do believe most people got it wrong.
PRP.
Yeah, I know. So I know, but like, yeah.
I thought that was the one you said.
Yeah.
Yeah, I don't even know how I answered that. That was a blur. Yeah, a couple of questions. That one and the last one. But I answered.
Well, the last one I just explained wrong because in lecture he was like, have a big list and have a small list.
Yeah.
But in the book it was like compared the smaller with the running. Okay. So I think I got the number.
I think Solar got it right.
He got a Solar got it right.
I think so. He was briefly explaining it to me after because
Okay.
someone was sitting there and then they were like, "Oh yeah, did you know chapter 9 was gonna be on it?" And I was like, "Huh? I don't think so." Because
Oh, yeah, I didn't know that was chapter 9.
Yeah.
I thought you just like randomly.
I know. And then Solar was like reading chapter 9 right before we went. I should have done that, but
Yeah.
I don't know. It can't be too bad if most people get that right.
Well, someone in the Discord said they didn't even get this last question on the last page. So they already lost 20 points.
No, that's not sad.
Like, I did talk to Bailey on the TAs, and they did mention that it was really, like most people got it wrong. So that's all. Like the last one and also the induction one with the number of leaves thing. Well, I'm just saying like, no, I'm not saying that. It's not like, I don't know. Maybe you're like not expected to know that or something.
I don't know. Was it explicitly said? I think.
Yeah.
That's what it
Oh,
was.
yeah. He briefly mentioned it in the review, like, oh, min-max, but we didn't go over min-max in the review, but we did it in a lecture.
Yeah, but even that, like, it could have been min-max anything because he said selection sort first, and then he went over min-max. But I think selection sort was just mentioned by someone. We just wrote it on the board. So, and like selection sort literally takes the min and the max.
Yeah.
So I was just confused.
Wait, so they started grading it. Well, obviously.
Yeah.
Do you know when we can expect more grades?
Or like what does it look like right now?
Seems like I think they mentioned next Monday the grading should be completed.
Damn, so
progress,
right?
I mean, they hate us so much.
No, it's just a couple of grad students who are just taking some.
Is it 2 TAs?
Yeah.
2 TAs grading.
Right? Or who's the one that gave me like
a lot of points on probably like. Kidding. I don't. That you're kidding. I'm kidding.
Well, they're not gonna hear it. This is only for the LSS class. This is only for the purposes of the LSS class. So only like an LSS, like
So you're not gonna snitch on.
No, so he's trying to make us talk shit. So
no. I don't even need to record. I don't have to record. It's not- I am confusing you guys saying one is like you guys got it and stuff like
No, I just said seems do.
okay. Because it doesn't like I looked at it, it didn't look good. Like I first saw this question like a month ago. It did not look good to me. Like
Oh. Well, I get the concept that 9.1. I don't know what I haven't yet. But I don't understand like conceptually. Randomized select, like the algorithm.
randomized.
Yeah. Which is nice.
I think I understood it, but I wouldn't be able to like explain it to you.
Like how this, yeah.
Yeah, we can definitely just go over that.
So then do you also want to go over 9.1 questions now that they're favorable or intuitive?
Yes, 9.1-1 is as hard as the next question. I don't think you guys should want to do that. It's just like show how to find the second smallest element and n plus log in this two comparisons, not just like insanely hard. Like I would never be able to solve this question if I didn't know the answer. Like
How did you know?
I actually saw like a month ago, I was in like a club meeting and then one of the presenters went over this exact question.
Oh.
And yeah, so that's kind of funny how I've never seen this question in my life. And in the last month, I've seen it in 3 separate instances. But but yeah, like even like when I first saw this question, I was just like, I saw this after the min max one. So we went over the min max one, the 3 and over 2 comparisons to find the max and the min. And like I kind of understood the idea behind that.
Wait.
I don't. Was that the min max question?
Yeah.
I think my brain is blank. Okay, sorry.
Yeah, because it asked how many comparisons.
Yes, I didn't say how many.
Yeah, you can't use asymptotic notation. You can't say it's like O then comparisons. It's just like exactly 3 and over 2 comparisons. And this one is just like
I put 3 and over 2 minus 2.
yeah, that's exactly right.
Then you got it right.
Well, no, I got that right. I don't think I explained the actual like process right.
Yeah, but essentially his question is extremely hard. That's all I'll say. We can go randomized select because that's more important. This is a very niche question. It's just asking you how to find a second smallest element, and it's just some obscure algorithm that is not related to anything else in this class. Like when I first saw this, I was like, how does a login appear? Like there's a login term in for comparisons, and that doesn't translate to any algorithm that I can think of. Like it's like binary search or like or something, or like a heap or something, like max heapify or something. But I was like so like lost. Like I can't even like get started on this question because I don't know what login algorithm can be used but yeah, we can go over randomized selection for it. That's a much more
Simpler.
yeah, it's more important. You don't need to know not whole that. It's just like how well you should go over it in class or something. You shouldn't like put it on the homework and say like, okay, well
I feel like sometimes you just randomly pick yeah. I know they're so hard sometimes. I skipped one last week because it was so hard. Okay.
I feel like
11, 4, 14. Yeah. And dynamic. Yeah. Isn't that
That's what we
talked
did
about?
today, yeah.
I saw the just for that personal.
Oh.
Yeah.
So what they were trying to do with it. So I feel like always take your pieces, essentially is like the road. Maybe
House from the long term.
if you all want like, because I don't like I'll use it for one assignment, but yeah, it wasn't insane. You have to use it?
No, it's never.
Good.
Think, Danny, you
You
use law tech, right?
Yes, I do use LaTeX for all of these, and I do use it for all my work assignments for like 2 and like 201. Math and like my math classes and stuff, but yeah.
When did you learn?
When I learn, it's not, I mean, there's a very like small learning curve, right?
I don't know, never.
I mean, it's like
Or tested.
Markdown kind of, right? Markdown. It's, I mean, it is very like simple. It's just a text editor or like a text formatting language, and I don't know, it doesn't require that much, right?
Well, yeah, I learned it, I had to learn it for 185.
Yeah.
I guess what made you? Just like,
Yeah, because in 13, they recommended using LaTeX and I never looked at it and I saw an example and I was like, so yeah, no, there's no way I'm like, yeah. I was like, there's no way. They were me. See, there's so many pictures.
Yeah, we're randomized selecting. It's cold, it's raining. Yeah.
do you have a jacket?
I do have a jacket.
Just got concerned for you.
I was wearing it when I walked in here. I took it off, but
Sorry.
oh. Okay. Yeah, so randomized select is just, you have some array and you want to find the k largest element, right? Like here we're trying to find, like, suppose this was our array, we're trying to find the fourth largest element. We're just passing these two values into this function here. And I'm trying to like simulate it. So it's very related to quicksort in that it uses the partition function. Yeah, if you just run partition on this array, and we'll just assume that you take the last element as the pivot. Did you guys go over this in class? All right.
I didn't go to.
Oh, no, it was before the midterm.
Okay.
So
Oh.
I didn't go to that
was
one
out of
either.
here.
I was
really
sick,
paying
yeah.
attention.
But yeah, it's actually quite like, it should be pretty intuitive if you understand partition.
So you're just randomly picking a pivot, or?
Yeah, you
Okay.
randomly pick a pivot and then you partition it. So let's just say we had this array, we ran the partition function, we picked 11 as the pivot, and then what we do is we take all the elements less than 11 to the left, all the ones greater than all to the right. So 10 is less or greater, and then basically from that, you can deduce that 11 is the second largest element in the array, right? Right, because right, because like what partition does, it puts all the smaller ones on the left, and all the greater ones on the right. So we know that 11 must be the second largest element in the array. And that's basically the only thing we know here.
So we know that the fourth largest element has to be to the.
Yeah, in the right.
Yeah.
In the right. And also we know that like, so what we do from here is we'll call randomized select again, we'll recursively call ourselves.
Within A 25 and 420. Partition starts with the left.
No, he picked 11 as pivot, so it doesn't, because it preserves relative order, right, when you still do partition. So that's why they.
Yeah, Sneha's exactly right. The relative ordering. So in other words, when we call partition, all partition guarantees is that every element less than the pivot is on the left, and every element greater than the pivot is on the right.
Yeah.
So in other words, all we know about 20, 25, and 12 is they're greater than 11. So we don't like, it actually doesn't matter what order these are here. We can, essentially, all we know is that these are the elements that are greater than 11, but we don't.
Actually, when partition runs, it starts from the left, right? So if 20 is greater than 11, it leaves it. 25 is greater than 11. And when it sees 10, it swaps it with 20, you know?
Yeah, probably. Yeah,
Mark asked it because like
yeah, Mark.
is there like a right or wrong? Which way does it end up?
Yeah, so that is a good point. The point, I mean, so Mark, we'll just say you're like, what's a good example of this?
No, I'm saying this specific.
Yeah, no, I know.
Sword
No, you're
stable or not?
It's no,
Quicksort isn't stable.
It's not stable. Partition is not stable.
it's not, yeah, partition is not
You
stable.
guys are talking about relative
So,
order.
Sorry, Mark, sorry, ignore the relative ordering. I'm trying to think of a good example. Yeah, so suppose you like, you have like a group of people, you have a group of 10 people, and you say like, sort them by height, you know, we have 10 people, sort them by height. Or sorry, we have 10 people, let's just say sort them by birthday. Let's just say like, we're sorting them by birthday, like what day they're born. And we have 3 people that have the same birthday.
Right.
Then how should these 3 people be ordered relative to themselves? Like they have the same birthday, like, right? So like,
But what is that? Is that related to this?
yeah, I'm trying to like make a point with this analogy. But the whole point is that if you're sorting these people by birthday and they have the same birthday, it's undefined behavior as to how we'll sort those 3 people with the same birthday. So in the same way, hey, this is kind of a
Undefined and stable. It leaves in the same order that it's stable. If they're not, it's not stable.
well, I guess kind of the point I'm making is that partition is it's kind of undefined, like how we order these things, like yeah, it certainly could be like, as you mentioned, it could be 25, 20, 12. So it certainly could be this.
No, pseudocode. I mean,
I know.
shows
Yeah,
how
I know.
it's done. I mean,
I know, but like, if you think about how quicksort works, it doesn't matter how these are ordered. All that matters is that every element greater than 11 is to the right. So in other words, we can just like have like a set here. We just have like a set of items like 25, 20, 12. Like it doesn't, like the ordering on the right doesn't actually matter. I'm not trying to like you definitely might be right in that if you do analyze the pseudocode, it might be 25, 20, 12, or it could be like 12, 25, 20. But it's not the takeaway here though. But the takeaway is that partition has 3 guarantees, and like you could implement partition in certain ways in which it would be 20, 25, 12, or 25, 20, 12, or whatever, but it doesn't like, I don't know. It doesn't like all partition only has like these 2 guarantees basically, where it has a pivot and then it like it based on this pivot, it like, you know, puts 2 every other element into like two groups, right? Okay, I don't know. I don't know if I'm making a valid point, but
My question was just which way was the
Okay.
way of the book
Okay.
is.
we'll have an unordered set of elements here, Mark. How about that? We'll have an unordered set of elements being 25, 20, and 12. So there's no order whatsoever.
I think it's just trying to say it doesn't matter for the bigger picture for now.
Yeah, yeah. So in other words, like we can just assume these are unordered here. Like that's how loose this is. So this is an unordered set of elements between 12, 20, and 25. And we're not assuming anything about the order at all. Like and partition would still work. It would still work with clicks and quick select. It would still work in this in quick sort. It doesn't like I don't know. It is a great point. It is a fantastic point, Mark. It is a great point. It just like it doesn't need to like sort it in any way. It's the magic, right? I don't know. Does that make sense?
Sure. Just one way that it's done, you know what I mean? The way it's in the book, it's all the same. You say it doesn't matter. I understand it doesn't matter. I know that conditions just takes elements to the left and the right. Saying if there was a question in the exam or something like that, it
Oh.
wouldn't matter. You know?
Good point.
Matters
Good
for
point.
such more left between the right.
Good point. Okay, yeah. I guess if you were asking like see like the partition function on an array, then the order might matter.
It would be different if it starts from the left or in the array or from the right. It would be different, you know, different result.
Okay, yeah, good point. I guess I am yeah, okay, I guess you do make you're totally right. Okay. Okay, we'll just go with like 25, 20, something like that. Because well, at least for the purpose of randomized select that we're covering right now, it doesn't okay, enough tangents, but yeah, all that happens is that we picked 11 as a pivot, and we know for a fact that 11 is the second smallest element, right? So Sneha, as you mentioned, then the fourth smallest element must be in the right half, and we will just make a recursive.
But that's for,
right?
sorry, that, I'm doing that basically with this. Oh. Yeah.
So yeah, so in the first call to randomize select, we have this is our original array, and I equals 4. In other words, we want to return the fourth smallest element in this array. And
So we're just taking the ordering of
This
the
result.
position of 11 in the previous array and then subtracting that from the initial element that we want, initial I.
yes, the idea is that any element in the right half will be greater than the pivot and anything on the left. So so if we take the second smallest element from these three, it will be the fourth smallest element in the whole array.
So if we pick the pivot to be 25, then wouldn't 12 and 20 show up before that? Then are we gonna have another one run? Because they could be either 20 and 12 or 12 and 20. Wait, actually just continue. I'll just follow along. Don't worry about it.
Yeah, so I did make the assumption that we picked 11 as the pivot. We could definitely explore what happens if we had picked a different pivot besides 11. So we'll just say like so if we had picked 25 as the pivot, every element it would be smaller than the pivot. And because we were trying to return the four smallest array elements, and 25 is the fifth smallest, then we know the fourth smallest element must be in the left half. And then we would just recursively call I equals 4. Does that kind of sense? And lastly, if we had picked and the last case you'll find in the randomized select algorithm is if we had picked the fourth element randomly as the pivot here. So we had picked 20 as the pivot. Yeah, we would immediately return 20 after partitioning.
So let's go from here. If you picked, going back to the original where you picked 11 as the pivot. Can you continue doing the rest? Like this, and then I equals 2.
Okay. I don't know if that's what I know.
Yeah, so once again, you would call partition
Yeah.
here.
Yeah, and then randomly pick a pivot. Let's pick 12. Then it would be 20 and 25, and then it would. So the next partition, we would be left with 20 and 25, and then I equals 2 again, right?
I equals 1 because we know that,
Oh, that's the
Because
third
this is
biggest
false.
element. Okay, thank you.
yeah, it should be it should be like intuitive as to like, if you understand the guarantees of partition, the partition function, it should make sense, like we have like, we're kind of splitting all the elements into these 3 groups. And, yeah.
So we can show that randomized select never makes a recursive call because there isn't anything to make a recursive call, right? Intuitively, that's the answer for 9.2.
Yeah, essentially, I kind of thought about it is there's like 3 cases, right? You pick some sort of pivot. So first of all, if the array is size 1, then that's a base case in the pseudocode. There's actually a hard-coded base case. If p equals r, returns AFP. I think you could just reason about the behavior, like, yeah, if you,
Pseudocode like P and R and stuff like that, are those indices?
so here I start with an array of 5, and when I did my simulation, I put it into an array of size 3 and then an array size 2. However, in the book, they have it as these are simply pointers. So we start with pointer with 1 to 5,
Okay.
and then I narrowed it from 3 to 5, and then from like 4 to 5, I guess. Yeah. Yeah. So how they always add is as like pointers. That's a lot more memory efficient than creating a new array and then passing that or new array as like a function argument, for example. So like yeah, it should be it kind of makes sense. You're just like if you want to make left out, just put this on.
Wait, so then in the line where they calculate K, like the K equals Q minus Q plus 1, is that the index of like? What is K?
K is the number of elements on the left side.
So
Like K is like 2. It just like here, like for example, here when we're trying to return the 4th element, and we pick the second smallest element, which is like 2. All we're saying is that like it's just 2. Basically, K is just 2, for example.
so
So yeah, in my example, we pick like the pivot as the second smallest element. However, in the way they implemented it in the textbook, they always have like 2 pointers, right? So like we could have some elements that were already eliminated in the left half of the array. So like basically the indices don't necessarily match, like this could be like the 6th index, but it's only the second smallest element with the subarray we're currently considering. So that is why they
okay.
yeah, even here they could have there's a cleaner implementation for this function that the pseudocode is. So why do they do this? it's like it's so like there's a lot more intuitive explanation. You just like think about like subarrays and
Yeah.
like here kind of like we'll just like in the pseudocode how they have it is they always use the same array and just two pointers, but like what they really should be doing is like calling themselves on a subarray and like a new line like
Yeah, like I get what's going on. It's like the big picture of randomized select, but it's when I look at the pseudocode, I get like lost with all the P and all.
the pseudocode is bad. The pseudocode is bad. It's really it's not like just make a new array. Like
Yeah.
it's the same runtime. It just takes more memory. So it's like I don't know. I don't know. I could have written it better too. Like a more clear pseudocode. 100%. But does this kind of make sense? Like, yeah, I guess, yeah.
I think for me to understand the pseudocode, I just need to go through it by hand, like line by line with this pseudo.
It's just like, I don't know, even with the way they implemented it, there's a much clearer implementation.
It's just like quick start, where it just takes the one partition set to
Yeah, like this is all that really matters is that you're like all you need to know about click select is you partition it, and given that the partition, you know that the pivot is like the order of the pivot, right? So we pick this element as 11 as a pivot. We know after running partition, we know the pivot is the second smallest element. So you will know like the pivot is what smallest element, and depending on that, you can determine whether the ith smallest element is in the right half or left half of this pivot, and that's all that really matters. But the textbook overcomplicates this with P, with R,
Yeah.
with this K value, with I, and it just it is a little excessively complicated. But yeah. But that's all that really matters. Like I don't know. Like that's how I would understand randomized select. I do not understand like yeah. But yeah, that's kind of I mean yeah. And I would be willing to go over 9.1-1 if you guys want. 9.1-1, the determine the second smallest element of an array at n plus log n minus 2 comparisons. What a funny expression there, eh? N plus log n minus 2. What does that mean?
ceiling.
Well, okay, just ignore the ceiling for now. Like, because the ceiling is just like it's just little. It's like if n is odd, and it's like the ceiling. But like, we'll just assume n is a power of 2, so the ceiling is equal to the ceiling of log n equals log n. But I mean, as long as this makes sense, that's kind of like the most important part. Also, probably dynamic programming. But,
We just got into that.
Okay.
So
okay. It's
that might be an fatigue question.
you guys are you guys good at dynamic programming? I don't know.
Yeah, we'll see.
It's yeah it could be beautiful. But I don't know if it is.
He said we'll talk about it more Friday.
Use a hashing tree.
Yeah. Did you do like Fibonacci numbers and stuff?
Yeah, a little bit of Fibonacci towards the end, yeah.
Yeah. Then I'll probably just
Oh, we did rod cutting.
Yeah.
yeah.
It's like a little introduction to.
Yeah, I think that's what he said.
Yeah, it's yeah. You do need a good foundation for dynamic programming, but it does. There might be a point where it clicks for you. I don't know, like dynamic programming clicks, like. But we can just do 9.1-1. So any ideas for 9.1-1? Any ideas? Come on, you guys just got out of the midterm. You guys should know how the min-max comparisons will.
Went through it one time, just keep track of the smallest and the second smallest.
Um,
You can do
Yeah,
like
so-
three. 2n minus 2 comparisons, right?
Um,
That'll be optimal.
I guess, yeah, the real issue is just the decreasing array. Because if you keep track of the smallest two you've seen so far,
Technically randomized that array before. And then it would be like,
well, that's a little dubious. You can just randomize it, right? And expect this is like a worst case n plus log n minus 2 basically.
randomized the array.
Like a deterministic n plus log n minus 2. You can't just shuffle the array and pray that the second smallest one will appear somewhere early and then because that could work. Like that's honestly a good
I
thought.
know what you mean.
Because Mark, if you technically randomize the array
Yeah.
and then assume that one of the smallest two elements appeared in the first log n part of the array, that technically would work, but but it is a good thought. Admittedly, that's a very creative thought, but I don't think it would, so. Yeah, so kind of the issue with, so you're trying to determine the second smallest element. It kind of makes sense that we'll just keep track of the smallest two we've seen so far. And that will just go through your array and we'll just update this smallest two we've seen so far as we go through. But we kind of see that, but we just do that, like first we see a 5, and we see a 4, and we see a 3, now it's 3, 4, and then we see a 2, 3, and 1, 2. But basically, like, it's going to be 2n comparisons. Maybe 2n minus 2. I don't know.
Yeah.
2n minus x, where x is like some constant. I don't know. But basically, it's like 2x-ish. We'll just say 2n. I can't be bothered to think about like 2n minus 2.
So why is it n plus one?
Yeah, I wanted you guys to like okay, so
And this is worst case.
yeah, so yeah, so
It's 3 and 2, no? It's like, like if you optimally you do, instead of doing min max, you do min and second min.
But it's worst case. So we're not optimal.
also the thing is that like
It's the optimal way to find min and max.
yeah,
The answer is
3/2 minus 2.
Sometimes you put the max, you put min and second min.
But the same algorithm doesn't work because
So
it's actually the answer is actually it's yeah, so this is 2n and the question is asking you for n plus log n. So first of all, what are some log n comparison algorithms you guys know about? That's what I want to know. Binary search, guys, come on, binary search. That's a log n comparison algorithm. So like max keep 5 from the heap sort thing. Yeah.
You know that like dude on YouTube, he's like South Asian and he explains all the algorithms.
Wait,
Yeah, that dude.
Yeah.
You probably seen it.
Volley, black pen, red pen or something? I don't know. Do you know his channel name by chance?
Abdul Bari or something.
I have seen.
If you've taken CS, you've probably seen it.
Okay, there probably is some video about this exact problem that you can probably search up and it's probably like pretty good, but I don't know. There's no motivation for the solution, right? Like it asks you for n plus log n minus 2.
Well, it's a tiny thing. Said also find the
It's
smallest
like
element.
it's actually easy. Well, it's implied you do have to know the smallest, right? So you have an algorithm that determines the second smallest element, like, and you don't know the smallest element, second smallest.
So I guess you just don't pick a max, you only pick a min and go from there.
Yeah, you do need to determine the min first, the minimum first. But the issue is that, like, when I first saw this question, I never would have been able to come up with the solution on my own.
Yeah.
So yeah, okay. So we'll just kind of go over the solution. I can't be
Are
bothered.
you saying we're less smart?
No,
It is true. I'm kidding.
Well,
I was just, yeah.
it's not that, it's just that like,
No, don't worry about it. That was just like a joke. Don't
Okay.
worry.
no, but I mean, it's
My humor's weird.
there's no like, there's no sort of background information you could have, possibly could have to prepare you for this question, that's all I'm saying. Like, there's no reason for you to ever know the solution to this question, like, there's no way, like, there's just, you just have to know it, like. I don't know, but like,
Did we just start comparing that element with the rest of the element?
okay, so yeah, so, how many comparisons does it take to determine the minimum of an array?
And minus one.
And minus one, yeah, so,
So we need one and then two. The second.
so yeah, in other words, we need some sort of algorithm in which we take n minus one comparisons to find the minimum. And then after that, we need to take log n minus one to find the second smallest.
Do we make a binary tree with the minimum at top and then just compare the rest of the tree with it? Or like a heap, like a min heap?
You're already further than I got. That is correct. You do make a binary tree with those minimum as the root. Like, okay, okay, so yeah, so, okay, so,
Well, you gave us a hint. You said, what are some log n comparisons?
yeah,
algorithms? So like you did give me that.
yeah, so.
Every hour, I just put on stuff. Like I just kept.
Yeah, so given the question and how it's phrased, it gives you this hint. It gives you like n plus log n minus two. Perhaps you could deduce this, you know. We know it always takes n minus one comparison to find the minimum. Therefore, it's kind of like, I don't know if it's exactly implied, but maybe you could assume that we, after finding the minimum, we somehow need to take log n minus one comparisons to find the second smallest. And as Sneha mentioned, you could like, if it's log n, that's kind of implying a binary tree. It just like there's nothing like, there's no like feasible like, maybe there are, but like there's nothing like I can like I've ever encountered that like does this. Like, I mean, there is like one algorithm called binary thing, but that's not really, but you know, it does kind of imply that there's maybe some sort of binary tree. So maybe you kind of reason that maybe there's a binary tree involved, right? So like,
I mean, tell me, it's gonna agree me even worse.
Right? It must be so hard to come up with these questions.
you want to know who?
No, it's a Bailey.
It's all it.
It's Bailey's friend.
It is. Apparently, like the 3 and over 2 one, the min-max one.
Oh, wait, he was the founder.
Bailey?
No, the guy who came up with the algorithm.
Yeah.
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 Wait, did he also write the book? Chang was
No,
the
no.
of the department here or something, right?
Oh.
Founder of the CS department here.
Yeah.
Oh, wait, how old was he?
When was that? When did he found?
Anyway, okay. 70s, 60s, late 60s, 70s. Just guessing, like maybe right before the AI, you know, the first.
As stated in that method.
All right.
David
so now-
Huffman.
David Huffman.
Is it him?
No, he said that in one of the lectures.
Yeah, he didn't mention the name.
Oh,
It's in a.
but it's the founder of the basketball.
It's kind of,
Just for those
yeah, but we have some sort of tree as you as Sneha mentioned. So maybe you could get this far that we kind of assume that given it's log n minus one, that implies some sort of tree. So we'll have some sort of tree. And if there's a tree, then it kind of implies that there's n leads. And because we have an array of length n, we'll just plug the array here. So now now what goes in the other nodes, guys?
So why is it -1? It's because the root is taken out.
Because the root is taken out.
Because we already know that the root is the minimum of the array. And then so you did log n comparisons, but you're not comparing the root to itself.
Okay, so yeah, okay, so we'll just, so first of all, how does the minimum, so we'll just say we have this array here.
Mhm.
And as you mentioned, saying how the minimum should end at the root. How do you like do that? How does the minimum end up here? So so kind of the idea is that so like you're kind of assuming that the minimum is here.
But we need to get there, is what you're saying.
Yeah. We have some sort of binary tree here where we start with the initial array. So after 0 comparisons, this is the array, this is the current framework we have.
Can we just do the thing where we build it in the sequence? So like 5 goes first, 7, 6, 1, 2, 3, 4, 8. Can we just build it in that sequence first, and then from there, like call a function like heapify? Can you do that, or will that take?
Okay, I'll kind of walk you guys through the first step of this problem. So the first thing we're gonna do is actually, it's kind of like, we'll just imagine that these 8 numbers represent like basketball teams, and the number is their seed. Like this is the first seed, is the 8th seed or whatever, and we'll just have random matchups in the quarterfinals, and we'll say the lower seed always wins. So we'll just like simulate this playoff, right? So like. So yeah, so in other words,
No, we have time.
oh, we have time.
Backing
Okay,
up.
sure. All right, so yeah, so this is the first step of the algorithm actually. Does it make sense like how I built this? Like,
Wait, you find like other children.
yeah.
The smallest child.
The better team, right? The better team, better basketball team, right?
Yeah.
And they'll win. So the better basketball. So we have the quarterfinals, and then the best 4 teams move to the
And then,
semifinals,
yeah.
and
Next 2 teams, and
then the
then
finals, and
there's
then
a
the champion. Yeah. So
that's cool. Yeah. That's
So then the
that's
second smallest is the third.
the third child. The
Or the
second,
right child of the first node.
yeah,
um.
but we're not doing that.
So what have we done so far? We haven't with this playoff setup. So if you just imagine like you have an NBA tournament with 8 teams and they play matches like this, it takes 7 matches to determine the champion, right? So in other words, we have taken n-1 comparisons to determine the winner already. So now,
Oh, you need to rearrange the tree to make sure it's actually a binary tree. Because right now it's got a lot of duplicates.
so yeah, so as Caitlin, as you mentioned, the we're looking for the 6-second season team, right? And we basically from this free framework, I'm saying we need some sort of log n minus 1 comparisons, some sort of idea to find the second smallest from this playoff setup. So yeah.
The only person who would really appreciate that. Was he a possible? He's Chang.
I just provided another example here. So let's say we have 4 teams and the playoffs are a little rigged. So the best 2 teams play each other in the semifinals instead of the finals, and the second team loses in the semifinals, and then you know first and third team play in the finals, and the first team wins. So like, yeah, yeah. So what do we know about the second best team in this in this playoff format? We know that it has to have lost. If it has to have lost to the first team, right? It has to have lost to the best team, right? Because
Can we redo this then? Can we delete the-
As long as you do follow the 1-1, but you don't do the last.
Okay, yeah, exactly. So
Okay.
yeah, so in other words, the first place we know that the second best team had to have lost to the first place team, right? We know it must have lost to the first place team somewhere in this playoff bracket, and and we know that the first place team must have played log n -1 matches. So all we have to do is go through all the opponents of the first place team and check which one's the best, basically. Does that make sense?
Yeah.
Oh,
Smallest.
yeah. So you check we'll check 2, 5, and 6. We'll take the smallest of those three. Exactly.
Wait, so how is the login -1 comparison? Can you just, I'm so sorry.
Isn't it because you traverse down the tree? and
Yeah,
you
yeah.
log-
There's lot, yeah.
Oh, okay, because then there's login. Why is it -1?
-1. Because so like the first place team here played 3 matches,
Yeah.
and log of 8 is 3. So we're taking the minimum of these 3 elements, and the minimum of 3 elements takes two comparisons, right? So
Oh, okay. Yeah. Thank you.
and yeah, so yeah, that's kind of a I don't know.
Do you like this a lot?
It is beautiful, but
No,
it's
so, yeah, it's great, but it's just also so particular. Yeah. I wonder who
It's cool
wrote
because I know the answer. But
Yeah, but if I didn't know the answer, I would be hating.
that makes sense though.
yeah. It's just yeah. So it is nice, but like I could not have thought of this on my own, right? Like and Bailey should have it's something that should probably be gone over in lecture instead of giving you guys on homework for no reason. I'm just saying that like, you know, it's like maybe he should like link a YouTube video or something. Yeah. I don't know. I don't know, but like, and you're not gonna need this like outside of this tiny lecture, out of this tiny homework assignment. Like,
But it's
Unless
a
he
very
doesn't-
cool, it's a
Yeah.
very cool.
well, it's a cool solution, but like,
Yeah.
I don't know. It just it is. I mean, it is cool, right? Like,
We're so late.
No one else will know. the answer.
No one told me.
Don't tell someone.
Thank you.
yeah, but that's the question. So this is why like it is very strange that this is the first homework question for you guys. Like, like I don't know, like, but yeah,
You do all the homework.
yeah.
I just got released like yesterday.
Yeah. Or, yeah. Wait, you're a grader and a tutor for this class?
I'm not a grader, no.
Okay.
I don't have access to your guys' grades at all, actually. So.
I was actually wondering that. Like
Yeah.
when I was reading the text, I was like, I wonder if Daniel will know how he did on the answer before I did.
Daniel likes to check on his
It's not
students.
the answer to second.
Yeah.
4 to the midterm, so it's pretty good. After.
I was like, damn,
It's
dude.
yeah, show me after. I guess it'll fix it. Yeah, I just checked them. They look good.
Yeah.
Study.
Solutions, yeah, well, I think maybe you can take pictures of it. I didn't. I guess you can.
Or because I want to do the midterms to study for the final.
Yeah, I think that's gonna be a good choice. Also, just like next time he says anything for the final review, I'm just gonna like.
No, my like exam review notes are literally whatever he says, like scribbled on. Like I will not let anything he says slide. Like, ever down.
if I just like, sometimes I just spit out the answers that I've just memorized.
Yeah, that's certainly every word he's any professor says during the midterm review,
But no one does midterm reviews like he does.
Honest, I really like his midterm
Yeah.
reviews. I mean, the midterm was hard.
It's like a big
It was
cheat
really
sheet.
hard. Like, I feel like I wasn't surprised because of like the amount he said.
Like when you said the midterm was hard, Kate told me. And then we went into it, it was like, yeah, this is kind of fair though. Like
Yeah.
it's fair.
Yeah, that's good. Yeah.
But that's only because he did the midterm review. If he didn't do it, I would be crying on the midterm.
Yeah,
Mhm.
it helps.
Like the induction one kind of off a little bit.
Yeah.
Oh god,
Yeah.
yeah.
I
Oh,
messed
but
up on an induction and then.
well, I don't know if you know what he said, but he said most people got the induction one off and wrote it in
Actually, yeah. Remember the book.
Yeah. You got that one right, Mark?
I think so, yeah.
Mark was explaining stuff to other people on Discord too.
Yeah, just like one, but it wasn't.
No, but you
Not a
explained, yeah, but
But the recurrence stuff,
Yeah.
I was like, oh shoot, if
No,
no,
I
I forgot that'd be so hard.
I saw your notes and I like read the textbook. I was like, if they ask me this, you just
I
said,
just showed summation. Yeah, I didn't ask.
yeah, I was happy.
Gosh, if that's only fine.
He's probably gonna ask us stuff. I was so ready to prove the n factor.
That's gonna be on the final.
Okay.
Cause he was like, oh, I won't give it to you on the midterm, but maybe on the final. I wrote that shit down. I go on final.
He had some at the group.
Yeah, he did.
The fill in the blank.
Oh yeah.
Caitlin, I don't believe log of n factorial prove that is theta of n log n. I don't think that's gonna be on the
No,
bottom.
no, no.
Full transparency.
The theta is kind of given
Yeah.
from the textbook. It's 3.28. It's like
Yeah.
so he wants us to prove why it's omega of n log n, and you just do like a little bit of like
Yeah,
math.
he did it.
Yeah.
And then there's one online too.
Yeah. Oh yeah, the one that you sent me.
That was the one that previous.
Oh, big O.
All right. Yeah. Okay. Okay, guys. Yeah, we got through a couple of your questions. So, yeah, that's gonna. There are two entire chapters I did not go over today, namely the hash table and dynamic programming. But dynamic programming, you guys will go over in class more. So, I thought you guys should. I should say that for you. Let you guys explore on your own. But, yeah. Yeah. Yeah.
You have a session next week?
Yeah.
Oh, okay, because we were just gonna say we
Yeah.
won't be
I know. Yeah. Okay, you guys. Okay. All right.
Thanksgiving. So.
Yeah.
Thankful for you.
Yeah.
Yeah.
This thing's Timothy? Or it's like,
It's Thursday.
We get Thursday and Friday off.
no.
No.
Tomorrow's off. No. No.
I'll see you at 7 maybe.
Okay.
I can make it there. The rain and stuff.
Yeah.
Also, like, yeah, if no one's going, we'll let you know.
Yeah, that would be. That would be.
Yeah,
great.
because so you wouldn't have to come. Unless you like just hanging out here. I don't know.
But yeah, no, I'm driving home.
Me too.
So-
Yeah. If you want to go home too. I don't know.
I mean, it's a possibility. Like our whole always say.
Thank you. See ya.